All right, these are the notes for Unit 3, Worksheet Day 7. I'm just going to do some of these examples just to review some of the graphing. So again, remember all of these are in slope intercepts, so these look like y equals mx plus b. So this -7 is my y-intercept down here, and then I'm going to count up 3 to the right 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And then you're going to lay your straight edge down. Now, this, because we're not equal to, that is going to give me a dashed line. I don't want a solid line, and it's greater, so that means we are above. Okay, so when I make this line, I'm going to have to move it a little bit, and I'll adjust the type of line here in a second. Make sure you go all the way through that coordinate plane, and then I'm just going to make sure that I have that dashed line. I want to shade the region above this line, so that is this whole big area up here. All right, so those are where my solutions live. Now I'm going to ask one additional question here, and that is -2, 3 a solution to this one? And if I go here, -2, 3 would be this blue point right here. That is in the shaded region, so I'm going to say yes. So if that were in that non-shaded region, I would just say no. So make sure you are locating the point correctly. Let's look at one that has less than. So I'm going to slide over here to number 3. This one is going to be dashed again, and it's going to be below because it's less than. Now this one's a little bit trickier because we have to look at our b value, and we're not adding anything on here, so we're just going to start right at the origin, and then my slope is -2/5. So I'm going to go down 1, 2, to the right 5, down 1, 2 again, and then to the right 5. So I'm just going to adjust, if you're on paper, you're going to go ahead and just write that dashed line. There we go. And we are below. So we're going to shade in this region here. Okay, so we're just going to say all of my solutions live down here. Again, look at where that blue point is. It's the same blue point, -2, +3, which is right here. That falls outside of the solution area, so we're going to say that is not a solution. So if I plug, what that really means is if you plug in -2, 3, it's not going to work in that equation. All right, so those are pretty straightforward. Let's just look at some like vertical, horizontal type lines, right? On this problem, this is I'm going to look at number 5. This is HOI, so that's a horizontal line, and that means we're going to go to 6 here, and it is equal, so this is going to be solid, and it's greater, so I'm going to shade above. Okay, so I'm just going to go right here. There's my line, the area above, and then I'm just going to check that solution. Be careful, I'm going to change up the points on some of these. So when I look here, -1, 9 is up here, and that is in the solution set, so we're going to say yes. That's in the shaded area, so it is a solution. Now, these next few are not in y equals mx plus b, so we're going to have to get these into y equals mx plus b. So let's talk about how to do that. This is in that standard form. The good news is it's always kind of the same process, even though it takes a little bit, and there's a few things we got to look out for. Here I need to get rid of that x term. I always want to write the x term first, so that -7 I'm not going to put after the 8, I'm going to put it before, because I want to know what the slope is, and we have the tendency to mix that up if we don't. Now, we're going to have a couple things going on right here, and we're going to need to divide everything by -4, so we're going to have some sign changes. This is going to end up being a slope of +7/4, and then I'll have a -2. Remember, when you divide by a negative, you are going to flip this inequality, right? So that goes back to last unit. So we are greater, so this line is going to be solid, and we are going to be shading above where my line is. So start down here at -2. We're going to go up 7. 1, 2, 3, 4, 5, 6, 7, and then we're going to go to the right 4. So 1, 2, 3, 4. We're not going to get another point, so we're going to have to go down 7 and then left 4. And then here's my line. That's solid again, and we want to be above. And I showed that we can draw these arrows if it helps, especially as the slopes are weirder. in that area up there, those are my solutions. And then this is the area where that contains all those solutions. And then I'm just going to look at this point, -1, -3. That's right here. It just is inside that bound. So we're going to say yes. All right, the rest of these are going to be very similar. Just be careful when you divide by that number that's in front of y, that you are actually like flipping when you need to flip. And then on these last sets, these problems are, you know, I'm going to throw in some kind of like stranger ones, but I want to focus on 14 because we haven't done a vertical line yet. This one's weird. There's only an x, all right? So this is my Vux, but I'm not ready to graph it until I actually divide both sides by 7. So I get 7 is less than or equal to -2, right? This is that Vux, that vertical line, undefined slope. And then I'm just going to look at this. This is solid again. Now, normally I would say above, but above doesn't apply because when I go to graph this, x is -2 here. We got a nice vertical line. Okay, great. But there is no above, right? So on this one, I'm sorry, this should be less than. So instead of being below, there is no below, but there is. Where are all the x values less? That would be over here. Make sure you're shading in that entire region. So there we go. Let's test the solution they propose. So -4, 7, right, is up here. And that is in the solution set. So we're going to say yes. All right, so